Today we are going to talk about speed perception, which is a study we did to understand and measure perceived performance. And these slides are always going to be up. So all you have to do is remember the company that we work at, which is InStartLogic, and you can go to our GitHub page. So go to instartlogic.github.io, and there's a link to this talk. So you can either type in the whole thing or navigate that way, which is easier than remembering everything. So now that it is actually 2:30, let's get started. This is Parvez. And Parvez is this absolutely brilliant guy that I work with, and he does machine learning and computer vision. And he also freaks out whenever I tell him that he's brilliant, so I keep doing it to piss him off.
Hi. This is Estelle. She's always trying to pull my leg in the daytime, but in the nighttime, I think she writes all these books, which are very informative.
What we are going to talk today about, basically our talk is in 3 parts. We are going to talk a little bit about what objective metrics there are, what people are doing right now. Then we're going to talk about the speed index and perceived speed index, which is a way of visually representing performance, but using objective measurements to supposedly mimic subjective measurements. And then we are going to talk about a study that we did to actually see what metrics worked best. So to talk a little bit about performance, I'm going to make this smaller so you can see the full video. So I'm going to show you 2 videos, and then I'm going to ask you which one you feel was faster. Okay, who thinks that the Oriental Trading Company was faster? And who thinks that the auto one was faster? Okay, so I'm just going to finish these, and you'll see that the one seemed like it was finished. They both seemed like they were finished, but they weren't actually. And when you measure visually complete, the one that seemed slower was actually faster based on a metric, so it's not measuring perceived performance. And the same thing is true. It actually had a load time that was faster than the one that seemed faster. So here we are using metrics, but they're not really measuring what we think they're measuring. Or they are, but it's not what we perceive to be. So performance has to do with the time to load, time until the site is usable. It can also have something to do with jitter, whether there's things bouncing, like we just saw that ad come in. Responsiveness and smoothness, like if you're navigating, is it smooth or is it not performant because you're not painting in under 16 milliseconds. So this is what Google talked about. They talked about rail, but if you actually look at the color and the order, they're really talking about wire, because page loads comes first in the dark blue, and you want your page load to actually at least seem like it's behaving and doing something within 1 second. You want it to load within 3 seconds, and we know that someone who works someplace here, and I'm going to make fun of her, said she loads like in 22 seconds, but it's not her fault because she is changing the performance right now. But we're aiming for under 3 seconds because then people will leave your site. You want idle of 50 milliseconds. So you want whenever you actually use your UI thread to free it up every 50 milliseconds. So if someone actually does an action, you can react to that action. Animation and scrolling. You want to animate and paint the page, basically have all the JavaScript done in 10 milliseconds because you have 16 milliseconds between one frame and the next frame if you're doing 60 frames per second. So you have 10 seconds to do all of your whatever you're going to do in JavaScript so that you have at least 6 milliseconds to paint. And response to input is 100 milliseconds. You want to let the user know, like if they pressed a button or something like that, at least give them some feedback within 100 milliseconds so it seems like it's immediate. If you wait 300 milliseconds when they press a button for the button to depress or to start spinning, they're going to be like, did I actually press it? And they're going to press it again. We have grown impatient. When I was a child, I'm a little bit older than some people in the room, you could actually have a TV show on something for like 2 minutes. Now it's like 5 seconds, they'll show something and something else, or 5 seconds because We can't even wait for a page to load in 3 seconds. Okay, so performance has to do with the download speed.
One second. So rest of the talk is mostly just focused on the L of the rail, just the onload part of it. The other parts are not necessarily covered.
That is true. Okay, so we have a download, and so what are the number of resources and the bytes? We have the time to parse the page, which has to do with the file size of the above resources that you put in, the execution, which is the parsing of your JavaScript and the executing and the painting to the page, and then the perceived performance, which is the user's perception of the speed. So we have objective measurements. I'm going to skip over to this slide right here. We have objective measurements that basically enable you to measure how fast your page is loading. But as we saw with that first example, that doesn't necessarily measure what people are seeing. So what does it take for a page to load? When you load a page, you make your HTTP request, you type in the URL, and you hit send. And it makes an HTTP request, and it puts the port and the path and everything else, and it does a DNS lookup. Now, if you are on a mobile device, like if you are on your Wi-Fi at home, that's pretty fast, or at work, it's pretty fast. It goes right to the to do a DNS lookup. But if you're on a mobile device, you're actually going to the cell tower, going to the cell company, then going to the DNS server, and then it's going the round trip back, and then does a round trip to the actual server. So you're adding in a lot of time. So there's 12 steps, which are listed out here if you really want to waste your time reading this. But it's a long process that I showed here. But what's important to note is that if you have one file, you only do this once. But if you have one file calling many other files, you're doing this round trip many, many times. And style sheets are blocking and scripts are blocking. So, and you have to do a DNS lookup for each different, but you already know all this stuff. So, what we've realized is, and what you probably all realize, and when we talk about UX patterns to make it the site go faster, you're thinking about what are these subjective ways or these UX features, such as a loading thing that's spinning versus a loading thing that's just saying loading. If it's spinning, people are not waiting, and they feel like they're not waiting. It's kind of like when you're at the DMV, it feels like an excruciatingly long line. But if you're at the airport going from your plane to TSA, or out to luggage, they actually make it like a mile and a half. So when you get to the luggage, it doesn't feel like you're waiting that long. But you've actually waited an inordinate amount of time, but you've waited while walking, so it doesn't feel that way. So it's basically, this is a way of improving performance of the checked baggage when they really are not making your baggage come any faster. So I'm going to show you another set of videos. And I picked these two videos because they have the exact same load time, well, within 40 milliseconds of each other. But one loads in 8.7 seconds. And the other one in 16. The visually complete is the 8.7 versus the 16. The load times for the actual bytes to get down, what we were told with that metric is that they were the same. So the reason I picked these two videos was not to harp on Staples or on Wolferman's, but was to show that some people are using the load time as the metric, whereas we perceive that visually complete is the metric. And there's actually two different variables for visually complete. There's once it's visually complete, and then 2 seconds after it's fully loaded. So I'm just going to show you the web page test for this, and hope that internet is working. So in our first version of web page test, when we're looking at visually complete, it looked like Staples finished first, based on a metric, an objective metric that is in web page test. If we looked at last change, Wolferman's is much faster. If we look at document complete, Staples again is faster. And if we look at fully loaded, Wolferman's again is faster. So even the metrics are disagreeing with each other if we're using, to me as a user, to me visually complete, the words sound like it's the right way, but it's really fully loaded and when it's done. But am I your average person? So this was fully complete. It says here at the 4-second mark, it said that Staples was done, right? Staples had finished loading. It was 100% done loading at the 4-second mark. But then, oops, I don't know what just happened. So it was at 100% there, and I'm going to try doing this, and then it went back down to 77%. So that is what we call jitter, and that is a way of seeing jitter, but how do we measure jitter? And how do we know that jitter is going to happen? So web page test gives us a few other results. It gives us the visual progress, which basically inverted is the speed index, which we'll talk about in a second. And then it gives us a bunch of timings, and then it gives us the number of requests, and then it gives us the number of bytes. So you can see basically that Staples takes longer except for time to first byte, which for some reason we think is a really important metric. Is it? We studied that. So the film strip shows us visually complete, last change, document complete, and fully loaded. The graphs show us visual progress with a speed index of 4,462, which was Staples, which makes it seem faster than Wolfram's at 5,902. They show us all the timings, all the requests, and all the bytes. For those of you, let me just take it a step back. Time to first byte is the time that it takes for the first byte when you navigate away and you get your first byte back. Start render is when the first pixel that is non-white is painted to the page. Load time is the thing I was mentioning earlier. There's two types of load time. There's load time, which is on load, which is from this navigation start to document complete. And then there's fully loaded, which is, it's basically a metric that goes, okay, I'm going to continue going until you stop doing any changes for 2 seconds, and then I know you're really complete, and I'm going to go back and give you what that time was 2 seconds ago. And then there's a speed index, which is a proportional representation of how quickly that user content showed up on the page.
So sometimes you'll see people use first paint or first visual change. It's very highly mapped to the render, the second one that she's showing. It's just WPT has its own definition, but they're very similar.
So speed index is the metric of the above-the-fold visual quality. It's the quality of experience of how fast it loaded, but just measuring above the fold. It is part of the web page test, as I just showed you, and it was created by Pat Meenan. And basically, this graph shows what it is. It is that equation on the bottom, which is basically what the pink and the light blue are at the top. And because I am not going to explain to you that equation, Parvez is.
So I'm not from the web performance field. I came to it from computer vision, and people were using these definitions, and I didn't know what to make of it. So some of how I think about it is me trying to understand it from my own point of view. Imagine that you have some web page that's awesome, and it's magical, and you click, and it immediately loads, right? In which case, the entire visual progress will be right there at the 0, in which case there is nothing to load, so the speed index is going to be 0. All that the speed index is trying to do is to measure the gap between that and the particular curve. So the gaps are the blue bars are for the blue curve, red bars are for the red curve, how much is left, how far are you from getting to the 100%, and you are penalizing for however long it takes, right? So the longer you take, the more bars are left, so it's worse. So if you want a very fast or better web page, ideally you should maintain, remember, ideal web page will load immediately, which means that it will have speed index 0, so the farther along you are, the worse it is, right? So I like math. One of the things that fascinated me about the speed index is the fact that it's actually talking about how you get to the completion instead of just getting to a certain time point. Okay? It's not just saying that both the curves are roughly getting to a certain point at the same time, but they get to it very differently, and speed index has the ability to penalize for getting there faster versus getting there in like a jumpy, slower way. But one of the key things that's not usually mentioned in speed index is that the thing inside the integral, the visual completion, is measured by looking at the last frame and you're trying to compare histograms between the current frame and the last frame, and you're just trying to see how far you are. And if you get to the end, it's considered 100%, and you're just measuring it. Like I said, I'm from computer vision background, and it's well known that if you're measuring distance between two image frames using pixel similarity, there are certain problems that happen. I'm going to physically walk you through them so you get an intuition about what kinds of problems can happen. So fundamentally, if you're thinking about visual perception of anything, there are certain components that play a role. One is similarity of color. The other is similarity of shape. The third one is the similarity of the entity, object entity. So what I'm going to show you are examples from psychophysics or in the computer vision field where you can see that these things won't be mapped if you're using pairwise, pixel-wise similarity to make this compute. So here are examples that just evaluate in your head where all the images that I'm going to show have half white, half black. So it's a histogram of two colors, 50-50, right? So the difference between them should be 0. Is image 1, 2, 3. So it turns out you can do a lot with two colors in a square piece. And if you basically make a GIF or a video of these frames and you loop them around, the speed index for this will be 0, right? So that doesn't make sense. The second thing that's interesting is that, so you should try the left one out where you can actually hold your finger against the middle point. So you will see that the percept of the top and bottom color immediately switches. And as soon as you take the finger out, it'll go away. This is a well-known phenomenon. And the example on the right is from Ted Edelson's group in MIT. It's also a well-known phenomenon about how brain infers a shade. There is actually no shade, but you see a shade because you can't escape this percept. There are very famous papers of this type. So what I showed so far to you is that shape similarity and the color similarity go missing if you're doing comparisons using pixel-wise similarities. And the object entity we skipped, but I have a talk that's up on SlideShare where you can go into that result also. So for me, what was important was to try to capture what I see, and I knew that the equation was missing some of these things, so we were trying to fix this issue. There is a simpler way to do it. It's not the perfect way to do it, but there's a simple, straightforward way to do it, which is change the way the similarity is measured. Instead of using pixel-wise histograms to make the comparison with the target frame, we use something called structural similarity. It's a very well-known measure if you're into image processing. If you see, the top left image is the reference. All the other images are some kind of corrupted versions of that image, right? And the MHD, which is the mean histogram difference, to itself on the left is 0. And as you're going along away from it, it's roughly the same. It's 144, 142. So MHD is not telling you how the visual corruption is happening. But on the other hand, if you use the SSIM to compare, you'll see that when it's exactly the same, it's 1. As you are moving away from it, it gets worse and worse, and it's much more corresponding to how you are inferring these images. So all we did is to basically swap this difference into the speed index, and since it's perceptually much more representative, we called it perceptual speed index. So this is the new formula. It's just a sum. You're adding the blocks again, but the blocks now are computed using this particular similarity measure instead of pixel-wise similarity measure. Very simple, right? And then you're just summing it from 0 to wherever the point is. Now,
so if you have a site like Etsy, which loads in 4-point-something seconds, Etsy does a great job on performance, you're going to see that the SIs, the speed index, and the perceptual speed index are virtually identical. So I'm going to play this video, which fortunately is really quick, and you'll see there's no jitter. The page just loads in, and that's it. We should all aspire to be Etsy. And then I'm going to show you Ralph Lauren. And as you'll see, the SI, which is the red line, is saying basically we're closer to visually complete than the PSI, which is saying, no, there's a lot of jitter happening. So it's basically, the way the line works is at every 100 milliseconds, it would give you whatever number and that would be added. And that's how you get the SI or PSI. So as you load it, nothing comes in till the 500-second mark, or the 5-second mark, rather. And then there's a lot of jitter and a lot of painting, but because it's a dark gray, the SI is giving it a closer finish rating because there's less of a color difference. So the PSI one is just measuring, is better able to measure that jitter instead of just doing pixel loss. But they're actually very highly correlated. And
so this is a long-running experiment I ran with Pat. So Pat and I collaborated for a while. He sent us like Alexa 500 or 1,000 mobile websites, and there was a year-long running experiment where we did all kinds of analysis. What we found is that, look, the integral is the same. It's just we swapped something, so they tend to be linearly correlated. It's also because very few websites really have things that make them really fall apart, so they're complementary. The place, they're both trying to measure this aggregate completion and how you get to that, but they're using different ways. If you use speed index, the classical speed index that WPT uses, what you're doing is to be not sensitive to movements. And if you want to really penalize movements that are due to pop-ups or some kind of ad coming in, then, and you want to account for visual jitter that's through layout thrashing, we use perceptual speed index. So we also showed that essentially if the web page is simple and it loads simply, SI and PSI tend to be roughly similar. They don't change that much.
So this is the image. This is the two slides we had. This is a different rev of staples that wasn't the original one. But as you can see, SI was near 100% and came down, but PSI was basically going upwards. This is this sum total, right, as you're going towards the end of the equation. So that's what you actually want to see if you're measuring jitter. You might not want to be measuring jitter. We don't know if jitter actually makes your site perform less well, because there's no objective measure until this one to measure jitter. But how does it interact with performance? Do people perceive jittery websites as slower, or do they perceive that they're actually doing something? And this is the one for Wolframans, and both of them are kind of like, you can see the correlation, they just keep always going up and to the right. So speed index, as we've said, and we're just going to reiterate because I have the slide right here, they're both for above the fold metric. Speed index doesn't account for layout stability, perceptual speed index does, but they're complementary. One is not replacing the other. So if you want to find out more about PSI and SI, there is an open source on GitHub, and the actual code is right there. Parvez wrote a blog post on it. You can either type that whole thing in, or I put a bit.ly link up there. If you want to see them in action, speed index is in webpage test, and PSI is in the Google Chrome Lighthouse, which is used to measure the performance of progressive web apps. So this brings us to the study that we did, which is called SpeedPerception. So I'm going to read this to you, but SpeedPerception was a huge web performance crowdsourcing study that focused on showing videos and figuring out the subjective feelings that people had when two videos were loading side by side. Because when you say fast, what is fast? You know, I can say I'm super tall, and you take a picture of me, and if I'm not standing next to anyone, then I'm super tall. Yeah, I'm super tall. Okay.
So, I mean, what she's referring to is that, like I said, I came from a very experimental vision background, and everybody was showing a video and asking, is this fast? It's like asking, is this guy tall? It depends. If this is a Scandinavian guy, the bar is different. If it's like a pygmy, it's different, right? So it's a relative question. So we tried to phrase the experiment differently to understand what does it mean if I can show it to a grandma. Can she make the same call very easily without knowing any web development, anything?
Right. I mean, and performance is relative. You do expect something like Macy's, where you have 1,000 pictures loading of different products, to be a little bit faster than my blog, which is one purple bar and text, right? I mean, the other way around. My blog should load faster. It probably doesn't, because I do web performance for a living, but I do not do it on my own website. Okay, so a little bit about the challenge. If you wanted to do the challenge, here are the links. It was put together by, that's the team, and the crowdsourcing happened from July to September. And I want to thank everyone here, because if you were here during the summer ForwardJS, I announced and asked people to fill it up. And what happened is we got 5,444 sessions, so that's pretty awesome. So let's go a little bit back and just show you how it goes. This is a slightly different, we're updating it, so it's not exactly the way it looked, but what would happen is we would show two videos. They would start at the exact same time, and then you would click on the right or left arrow to see which one goes first. So here are two sites loading. And we had three hypotheses. The first hypothesis was that that visual metrics would perform better than non-visual metrics. So visual metrics, non-visual metrics are like time to first byte. Visual metrics are like render, or PSI and SI. The second hypothesis was that there would be no metric that could actually explain the human choice with 90% accuracy. And the third hypothesis was that users would not wait until visually complete to make their choice. So they were told explicitly in the instructions, wait until it's gray, but our hypothesis was that they wouldn't. So we did have 5,444 sessions, of which 51% were complete and valid. So we had 3 honeypots in each set of 20, and the 3 honeypots were like, obviously one was faster than the other, and if you didn't get the 3 correct, then we assumed that you were not paying attention. Actually, it's 2 out of the 3. We assumed you weren't paying attention. I think, right? We had a total of 77,000 plus votes, of which 75% were valid. And what this histogram shows is that we had 160 pairs of videos. So you saw 2 videos there. So there was 160 pairs. And all the pairs were displayed between approximately 240 to 330 times. So we had a huge number playing this game. So we were able to really assume that these results were valid. We also had feedback, and the feedback that we got a lot was the pop-ups. So that wasn't necessarily what we had looked at, but it really did explain to us that the UX is strongly impacted by jitter, which is the pop-ups, stuff coming in from the side, modals. You can't go anywhere if you don't sign up, even though this is the first time you've ever come to our website. Don't do that. Okay, so I'm going to let you talk about the 3 hypotheses.
So we had an experiment, so we set up 3 hypotheses. When we first did the analysis and we pushed the results out, it's on GitHub. In October, when we publicized, what we found was that, so majority explains 75%, which meant that there is actually difference in opinion, but there is a dominant group, and it explains the group 75%. So it's like you had an election, there are 3 ways you can vote, 1 vote is 75%, so it's a pretty dominant majority. Each group, what it is doing itself is very interesting. I'm not going to talk about it here today. But what we found in that result when we went public was that only render was in the top 3. So originally I was expecting to see all of the top 3 to be visual metrics. I didn't see that. So that was very surprising to me, because the question that we asked by showing 2 videos was a very visual question. I was expecting visual things to show up at the top. But so we basically asked ourselves a few questions. For example, did the presence of visual jitter or modals interfere with how the metrics did? Can we actually do better versions of these metrics? How do we do that? Second was that if we can somehow find websites that are free of these visual jitter, like for example, internet retailer, there are lots of signups and lots of sales, so there is a lot of movement. For Alexa Top K, it's less so, because there are news media websites, they have different behavior, so would it be different for Alexa? So the phase 2 that is going to get launched in a few weeks is going to address these questions. And the other thing is that I do machine learning. I was curious whether I can teach a computer to tell when you give me a website, whether this website contains all kinds of jitter and name it essentially automatically. We have some results that will go public at some point. So these questions led us to, this is probably the only board slide. What I'm trying to do is, at the top is the equation that you saw before. And all we did is to try to figure out what's well known is that because it's integrating, the sum is from 0 to the end visual complete. I was trying to find out if I can pull it back to some point where it's reasonable so that I can leave all the modals and the pop-ups on this side, right? So that I can denoise it. But then I have to do it in some way so that you can also look it up from the synthetic metrics that's available in the browser API. So we played with lots of things. For pairwise measurements, it turned out that the time to click that we were recording from the experiment was a very good marker, but time to click is not available in Chrome or Firefox APIs. In the single video, we basically came up with essentially ending the integral at onload, right? Because onload is available. So essentially what we found is that we made up two versions, speed index 2.0, PSI 2.0, which essentially are the old equation, but they end at onload. And then we went back to the board again to see what happens. So what we found now is that once you make that change, all the things that have essentially these stripes are visual metrics, and the hypothesis holds. Like with the new modification, the measures actually explain how people are making the vote much better. We actually found that PSI and SI, especially with the onload endpoint, almost explain 80% of what people are doing. So this is actually very interesting. The summary is that our hypothesis number 1 is now true if you use the right metric. And we have some metrics that we have in hand. I'll probably write some pointer up, put it up. The code for it, as Estelle said, is on GitHub. So it should be usable if you want to play with it in your own time. The hypothesis number 2 was that no single metric can explain human choices with 90% accuracy. So why did I put this up? Because when I talk to my salespeople in the company, they would all tell me, hey, it's like some X metric that sells. But I never could convince myself looking at all these different websites that they're saying the right thing. So I was looking for the unicorn metric. And the conclusion here is that there isn't one. But once you actually make the change, where you have these PSI and SI computed in the new way, the top 3, which are visual metrics, there is a way to combine them that turns out to give you a unified metric that's almost 90% accurate. So that result is not public yet, but hopefully we'll put it up soon. This is also extremely interesting, which means that there is a possibility to construct something from just recording of a website from a WPT video that can almost do as good a job as everything that's in your HAR file, right? We basically saw that there was no unicorn single metric, but there is a way of combining the top 3 measures that seems to do extremely well. That's one of the things that we found. We also basically were thinking about, can we do modeling better, but that's not covered here. The hypothesis number 3 was that people won't really wait, even though at the beginning of the experiment we told them wait. And we wanted to see, do people wait? What we found is actually, so the greenish bar, the switch is when people basically start to click. And when it goes down, and so the intersection point is where most people have essentially decided that they are ready to make the call for the video. And it's unprompted. And what's interesting is that it's much before visual complete. It seems to be somewhere around load time. There's a paper from Telefonica that came out last year that's also saying that it's around that area. We have some models about how to predict it, but it's definitely a lot earlier than visual complete. My point is, if we basically in near future put out a model that predicts when this ready time is, then you could put your pop-ups and models between that point and the visual complete, and it won't really affect people. But don't put it in front of that, because that affects people, right? So it's interesting to know where that point is.
So there's a few things that we want to cover before we actually end. So we told you about the speed perception, but one of the things is I redid a web page test. So this is the exact same web page test. And these results up above are still pretty much the same. But it did not actually go up to 100%. It only went up to 78%. And I'll just show you with the visual progress below. Remember, it had gone all the way up. So the reason I wanted to show you this is because a lot of people test their website once on web page test. That's not the way to go about doing it because you don't know what the parameters are. You don't know what the network was at that instance. So what Parvez suggests is doing it 100 times and then taking the mean. He'll tell you what he actually says because I don't remember.
I mean, you should look at the histogram. You should definitely look at the histogram and look at the percentiles. But what we found is that the histogram doesn't look like a regular normal distribution. Do it at least 100, 200 times if you're really making an A/B test. Not doing it caused a lot of problems in my company that I had to fix. So don't do it.
So we are going to do a second phase of this study because the first phase was not really, we didn't realize that visual jitter was actually the thing that we would be really talking about at the end. So our second phase is going to take a look at whether pop-ups make people feel like, to me, it makes me feel like the website goes slower, I think, but I actually didn't test myself on it. So we are going to test that. And I probably shouldn't have told you what the hypothesis was before we put the study out, because that's a no-no. So we better not put this recording out until after the test is done. And then also another thing that the talk I gave last year was about a site that has a 2-second DOM content and loaded event. So it uses approximately 40 dependencies, and it has React. And it took 2 seconds after load for the DOM content load, and the CPU completely thrashed at 100%. And does that impact perceived performance? So you can't see that happening, but you can see it, in your flame chart. And if we look at Staples, they kept the CPU busy. Oh, I didn't activate on hover for over 25 seconds. Is that a good experience, or is that a non-experience? Does it not matter? So those are the things we're going to look at. But I do think it matters because when a site takes 20 seconds before I can interact with it, or when a site takes 18 seconds to finish when it really should have taken 4, like Etsy, I know I can react to it right away. Staples, I'm kind of like, are you going to be done? When can I interact with you? When you're using tools and libraries and frameworks, I'm not saying don't use them, but don't use them to benefit your development time, just for your development lifecycle, just because you want to pad your resume. The user experience of your website should always outweigh your personal experience in developing that site. So if we brought anything to you today, we had a few summaries, and I forgot them.
Look, I think what's interesting over the time to watch is that, initially all the metrics used to be network oriented. Then people started to be very fixated about TTFB, which was just before the, application level. Now there's a lot of talk about measurements at the application level. But truly, at the end of the day, it's a human being in front of a screen looking at it. So ultimately, that's the last stop, right? So how people feel and like being able to actually measure that and move it back into the measurement things would be a very useful thing to do. Luckily, a lot of the browser people and others that are in the web performance community do care about this. PSI now ended up in the Lighthouse project of Google. So our hope is to essentially build these things and give them out to the community so that when you're building your work or building your websites, you can essentially use the right measures that also explain how people that are going to use your websites are going to apply, right? I mean, so that it's closer to human experience.
Our basic goal is to figure out what the objective measure is for subjective feeling. So if you have any questions, if you want to follow up, the slide deck is at instartlogic.github.io. You can find the path to it there. And my name is Estelle, and this is Parvez. And we can be reached through Twitter or through our blogs or however else. And thank you very much.